Welcome to Python for Business Automation. This course is designed for professionals who work with Excel files, PDFs, reports, APIs, and repetitive business processes every day. You do not need to be a software engineer. You do not need a computer science background. What you need is a practical way to reduce manual work, improve accuracy, and build automation scripts that solve real business problems. By the end of this course, you will understand how Python can help you automate Excel reports, clean messy data, extract information from PDFs, connect to APIs, generate reports, build dashboards, and even use AI-assisted workflows. The goal is simple: help you move from manual effort to repeatable automation. This course is built for business professionals, not career software developers. If you are a consultant, you may be spending hours preparing client reports, reconciling files, or summarizing exceptions. Python can help you automate those tasks. If you work in finance or accounting, you may deal with invoice validation, AP exceptions, duplicate checks, or month-end files. Python can help you process those files faster and with fewer errors. If you are an ERP professional, you may regularly export data from systems like SAP, Oracle, Workday, or other platforms. Python can help you clean that data, validate it, and generate structured outputs. And if you are in operations or analytics, you may need to combine CSV files, create dashboards, or check data quality. Python gives you a practical toolkit for that. This course is for anyone who says, "I keep doing the same thing manually, and there must be a better way." By the end of this course, you will have built more than 35 practical Python scripts. These scripts are not abstract classroom examples. They are business examples that you can adapt to your own work. You will learn how to read and write Python using beginner-friendly libraries like Pandas, Pathlib, and OpenPixel. You will automate Excel tasks such as reading files, filtering records, flagging exceptions, detecting duplicates, and exporting reports. You will process CSV files, combine multiple files from folders, clean messy business data, standardize vendor names, fix dates, and create data quality scores. You will also learn how to extract text from PDFs, call APIs, generate Word and Excel reports, create charts, and build a Streamlit dashboard. Most importantly, every outcome is backed by a working script. You will not just understand the concept, you will actually run the code. This course is structured into 12 practical modules. We start with the business case for Python automation. Before writing code, you need to understand where Python fits compared to Excel, low-code tools, and AI tools. Then we set up Python and VS Code step by step. This is where many beginners get stuck, so we take it slowly. After that, we learn Python basics through business examples. You will learn variables, conditions, loops, functions, and dictionaries using scenarios like approval checks and vendor lookups. Then we move into Excel automation, CSV and folder automation, messy data cleaning, PDF extraction, APIs, automated reporting, dashboards, AI-assisted workflows, and finally a capstone project. The capstone is a business automation control tower. It combines everything you learned into a complete invoice automation workflow. Each module follows the same structure: business problem, code, output, and practice. Let's start with the problem. Every week, business teams spend hours copying data between Excel files, applying filters, formatting reports, checking exceptions, and sending updates. The work may look simple, but it is repetitive, error-prone, and hard to scale. If you do this manually once, it is manageable. But if you do it every week, every month, or for hundreds of files, it becomes a serious productivity problem. Python helps you replace that manual loop with a script. The purpose is not to become a full-time programmer. The purpose is to make your work faster, more repeatable, and more auditable. Python becomes a force multiplier. It does the repetitive work while you focus on review, judgment, and decision-making. Before we jump into code, it is important to understand where Python fits. Excel is excellent for quick analysis and small data sets, but when the process becomes repetitive, large, or multi-file, Excel starts to struggle. Low-code tools are useful when the organization has already invested in them. They are good for workflows and forms, but they may come with licensing limits and platform restrictions. AI tools are powerful for generating ideas, explaining code, summarizing text, or helping with drafts, but they are not always reliable for controlled, repeatable data processing unless properly governed. Python sits in a very useful middle ground. It is free, open source, flexible, fast, and strong at repeatable automation. It works well with Excel, CSV files, PDFs, APIs, folders, charts, reports, and dashboards. That is why Python is so valuable for business professionals. It gives you control over repeatable work. Now we move into setup. For many beginners, setup is the first barrier. They hear words like terminal, path, extension, library, and script, and they assume this is too technical. But it does not need to be intimidating. In this module, we install Python from python.org. During installation, one important step is to check Add to Path, because that allows your computer to recognize Python from the terminal. Then we install VS Code. VS Code is where we will write and run our scripts. After that, we install the libraries we will use in this course, including Pandas, OpenPixel, Requests, PIPF, PDFplumber, Python Docs, Matplotlib, and Streamlit. Finally, we run our first script, hello_business.py. This script prints a company name, today's date, and a confirmation message. It is simple but important. Once this works, your Python setup is ready. Now we begin Python basics. The key idea in this course is that we learn Python through business examples, not abstract theory. The first example checks whether an invoice amount exceeds an approval limit. This introduces one of the most important concepts in automation, business rules. If the invoice amount is greater than the approval limit, Python prints approval required. Otherwise, it prints auto process allowed. The second example checks whether an invoice number is missing. This is a simple but powerful validation check. The third example assigns a vendor risk category based on a compliance score. These examples introduce variables, if statements, comparison operators, and decision logic. This is the foundation of almost every business automation script. You take a rule, translate it into code, and let Python apply it consistently. In this section, we build on the basics. First, we look at lists and loops. A list allows us to store multiple values, such as several invoice amounts. A loop allows Python to apply the same rule to each item in that list. Instead of checking 5 invoices manually, Python checks them one by one automatically. Next, we create a reusable function. A function packages a rule so that you can use it again and again. In the example, the function checks whether an amount requires approval. Once we define the function, we can call it with different amounts and different limits. Finally, we use a dictionary for vendor lookup. A dictionary stores key value pairs. For example, vendor ID V002 maps to global logistics. This is useful whenever you need to translate codes into business-friendly names. These 3 patterns, loops, functions, and dictionaries, appear constantly in business automation. Now we move into one of the most important sections of the course, Excel automation. Excel is the universal language of business. Almost every business team uses it, but Excel work often becomes repetitive. You receive a file, open it, filter it, check missing values, identify duplicates, export a report, and repeat the same process next week. Python allows you to automate that workflow. In the first example, we read an Excel file using Pandas. The file contains columns like vendor name, invoice number, amount, PO number, and date. Once the file is loaded into a data frame, Python can inspect it, filter it, count rows, and check columns. Then we find missing PO numbers using .disna. This is a common AP control check. Finally, we detect duplicate invoices using vendor name and invoice number. These are simple scripts, but they solve real business problems. In this section, we go deeper into Excel automation. First, we add an exception flag column. This is useful when you want to label records automatically. For example, any invoice above 100,000 can be marked as review required. Then we split a combined file into separate files by department or region. This is a common reporting requirement. Instead of manually filtering and saving multiple files, Python does it in a loop. Next, we create a vendor summary using GroupB. This works like a pivot table. We calculate total amount, invoice count, and average amount per vendor. Finally, we combine multiple Excel files from a folder into one master report. This is one of the most useful automation patterns. If you receive monthly files from several regions, Python can read them all, tag each row with the source file name, and combine everything into one clean output. Many business systems export data as CSV files. CSV files are simple, lightweight, and common in ERP, CRM, finance, and operations systems. In this module, we learn how to read a CSV file using Pandas. The pattern is very similar to reading Excel, but the function is read_CSV. Then we combine multiple CSV files from a folder. This is almost the same pattern we use for Excel files. Find the files, read each one, add the source file name, and concatenate them into a single data frame. We also learn how to create output folders automatically using Pathlib. This prevents your script from failing when the output folder does not already exist. Finally, we rename files in bulk. This is useful for standardizing field names, adding date prefixes, and creating audit trails. Folder automation may look basic, but it saves a lot of time in real business environments. Before you can automate reporting or analysis, you need clean data. Business data is often messy because it comes from different systems, teams, regions, vendors, and manual inputs. In this module, we cover 5 practical cleaning patterns. First, we clean vendor names by removing extra spaces and standardizing casing. This helps avoid treating Acme Corp, Acme Corp, and Acme Corp with a trailing space as different vendors. Second, we standardize date formats. Dates often arrive in different formats, and Pandas helps convert them into a consistent format. Third, we flag missing values in critical fields such as vendor name, amount, and invoice number. Fourth, we remove duplicate rows after combining multiple files. Finally, we create a data quality score for vendor records. This gives you a prioritized cleanup list instead of a messy spreadsheet. PDFs are everywhere in business. Invoices, contracts, statements, and reports often arrive as PDFs. Manually opening each file and copying text is slow and error-prone. In this module, we learn how Python can extract text from text-based PDFs. The first example uses PIPDF to open a PDF invoice, loop through its pages, and extract text. The second example processes all PDFs in a folder and saves the extracted text into separate text files. This is useful when you want to prepare documents for downstream review or processing. The third example uses PDF Plumber and regular expressions to extract structured fields such as invoice number and amount. One important caution: these examples work for text-based PDFs. If a PDF is scanned as an image, you need OCR, which is outside the scope of this module. An API is simply a way for one system to talk to another system. For business users, you can think of an API as a structured data connector. Instead of manually downloading a file from a system, your Python script can request the data directly. In this module, we use a free public demo API so you can practice safely without credentials. The first example sends a GET request to an API and receives structured data. The second example converts the API response into an Excel file using Pandas. The third example sends data to an API using a POST request. This is similar to creating a new record in another system. In real business systems, APIs usually require authentication. That means you must handle credentials carefully. Never hard code passwords or API keys directly into your script. Use environment variables or secure configuration methods. Once your data is cleaned and validated, the next step is reporting. Many business teams spend hours creating the same monthly report again and again. Python can automate that. In the first example, we generate a Word report using Python docs. The script creates headings, paragraphs, key findings, recommended actions, and then saves a Word document. In the second example, we create a chart using Matplotlib and save it as an image. This is useful for exception reporting, management packs, and presentations. In the third example, we combine data and chart output into one Excel report. The script creates a multi-sheet workbook, writes raw data and summary data, and embeds the chart into the Excel file. This is where automation becomes very visible. You are no longer just processing data. You are generating a finished business deliverable. Now we move from static reports to interactive dashboards. Streamlit allows you to turn a Python script into a simple web app. You do not need HTML, you do not need JavaScript, you do not need front-end development skills. In the first example, we build a basic invoice exception dashboard. The user uploads an Excel file, and the app displays all invoices and high-value invoices. Then we add KPI cards using saint.metric. These show total invoices, total amount, and exception count. Next, we add a chart showing exceptions by vendor. Finally, we add sidebar filters so users can filter the data by department or minimum amount. This is powerful because it turns your automation script into something other people can interact with. AI can be very useful in Python workflows, but it should be used carefully. AI does not replace your understanding of Python. It accelerates your work. It can help you write boilerplate code, debug error messages, explain unfamiliar code, and generate test data. In this module, we use AI to generate a plain English report summary from exception data. The Python script calculates key metrics first, such as total exceptions, high-value invoices, and missing PO numbers. Then it sends those metrics to an AI model with a clear instruction: write a concise executive summary. The important principle is this: Let Python calculate the facts and let AI help with language. Do not ask AI to guess your numbers. Feed it controlled, validated data and ask it to summarize. Also, never hard-code API keys in your script. Use environment variables or secure configuration. Now we start the Capstone project. The Capstone is a business automation control tower. It brings together everything we have learned so far. The workflow runs in sequence: read the data, clean the fields, validate missing values, detect duplicates, score risk, and export reports. In part 1, we load invoice data from Excel and confirm the number of rows and columns. This is always the first step because you need to know your input loaded correctly. In part 2, we clean key fields. We standardize vendor names, parse dates, and convert amounts into numeric values. In part 3, we validate missing values. We create an exception flag column and mark rows where vendor name, invoice number, PO number, or amount is missing. At this point, we already have a working validation engine. Now we complete the control tower. In part 4, we detect duplicate invoices using vendor name and invoice number. We do this after cleaning because standardized vendor names make duplicate detection more reliable. In part 5, we score risk. The script adds points for different risk signals. For example, a high-value invoice adds risk points. A missing PO adds more points. A duplicate invoice adds even more. Then the script converts the risk score into a risk tier: high, medium, or low. In part 6, we export the full report and a separate high-risk report. In part 7, we generate a Word summary document automatically. And in part 8, we launch a Streamlit dashboard that shows KPIs, filters, and the full exception table. This is the complete automation loop: data in, cleaned data, exception logic, risk scoring, reports, and dashboard. There are many Python courses online, but this course is different because it is built for business professionals. We are not starting with computer science theory. We are starting with business problems. Every example uses familiar scenarios: invoices, vendors, reports, folders, dashboards, APIs, and exception files. You also get more than 35 working script examples. That means you are not just watching code. You are running it, changing it, and adapting it. The course also teaches the full automation stack. You learn how to read files, clean data, validate records, generate reports, and build dashboards. And importantly, beginner mistakes are taught directly. You will see common errors before you make them. The final capstone gives you something practical that you can show, reuse, and adapt. This is not just a Python course. It is a course about getting business work done faster. This slide summarizes how the course should be positioned. The course teaches Python to business professionals through practical automation use cases. It is not designed for advanced software developers. It is not a data science or machine learning course. It is not a theory-first programming course. It is designed for people who work with Excel, PDFs, reports, APIs, and repetitive business processes. The ideal learner may be in finance, accounting, AP, ERP, shared services, consulting, operations, or management. The only real prerequisite is comfort using a computer and basic Excel familiarity. If you have never coded before, that is fine. The course starts from the beginning, but the learner must be willing to practice. Automation is a skill. You build it by running scripts, breaking them, fixing them, and adapting them to real work. Let's close the course with the bigger picture. You started as a business professional who may have been doing repetitive work manually. Now you have seen how Python can automate Excel files, CSV files, PDFs, APIs, reports, dashboards, and AI-assisted summaries. You have built more than 35 scripts. You have built a control tower. You have built a Streamlit dashboard. You have generated Word reports and Excel outputs. You have created a data quality scoring system. But this is only the beginning. The real value comes when you take these scripts and adapt them to your own work. Pick one task that you repeat every week. Maybe it is a report. Maybe it is a file check. Maybe it is a reconciliation. Maybe it is an exception tracker. Use the patterns from this course and automate that task. The best automation script is not the most complex one. The best automation script is the one that saves you time next Monday.